So from here, we're going to go ahead and just open up the center drill. And there's two ways to do it. The first way is the tried and true SOLIDWORKS method, which is you right click on the feature and you go to edit definition. If you do that, it'll open up the dialog box, which we'll get to here in just a second. The other way that you have to access these types of features inside of CamWorks is you have the ability to just double click on the feature, and that will bring up a dialog box. Now, in the dialog box, you can see that we have a basic center drill picture of how the tool looks. We have information on how the diameter is going to be. We have cutting parameters, whether it's a left hand or right hand cut. And if I go to a mill holder, it tells me what diameter and size of mill holder we have. And the cool thing about this is you have the ability to adjust any of this information. So if I click here and I go to translucent, you can see that it shows how far the tool sticks into the holder, all that kind of cool stuff. But you have the ability to do a user defined, which gives you the ability to adjust the protrusion length. Or if we stay in basic, we have the ability to adjust the diameter of the holder, the overall length, any of the information we want to add. And then we can put a comment down here. So if you were using a collet versus just a standard 40 taper holder, we have the ability to adjust how that's going to be perceived inside of CamWorks. And this comes into play when you're doing 5-axis, 4-axis machining and you're worried about collision. Over here, we have the tool crib, as you would expect. This is a list of all the tools we currently have. And then down here at the bottom, one of my favorite things is it shows usage. How many times a particular tool is being used. And what this allows us to do is minimize the number of tool changes or minimize the number of tools we have to have in certain spots in the machine because we're going to use the same ones. So for example, these are all listed next to each other. So if our turret moves efficiently, you know, in a group where they're together versus spinning all the way to one side, spinning all the way to the other, we have the ability to group these so they're in their correct station next to one another. And then the last area we have here is the tool number. Again, this is a center drill being used. It's tool number 52. And then it also tells us how many operations are being used for this. So you have the ability to set your XYZ offsets for gauging. And then we also have a quick reference of where, when, how, and why this is being used. From here, we're going to take a look at our Speeds and Feeds tab. And our Feeds and Speeds tab gives us the ability to enter information. Now, you can enter this information by the specific operation or which one it's going to be used at. You can have it defined by the Tech Database Library, where it looks at the feeds and speeds, which comes with it. And then we also have the ability to adjust it by tool. So let's say you had a 1/2-inch end mill, but you bought a special 1/2-inch end mill just for one operation, and you want to define the feeds and speeds just for that specific tool itself, not in a general scenario of just using a high-speed steel cutter. We'll just leave it on operation for this example. And then one of the cool things about this is if I put in the spindle speed, let's say we're going to spin this at 5600 RPM. Might be a little fast, but we'll just go ahead and put it in there. And if I hit the tab key, you'll notice the surface feet per minute automatically updates. One of the nice things about these dialog boxes is these all work in conjunction with one another. So if I go to feet per revolution to 3,000ths per tooth, which is how it's calculated, you can see that it goes to 16.8 inches per minute. The cool thing about this is some tool manufacturers like to give you surface feet per minute, and then they like to give you feet per revolution versus Z rate. Well, it doesn't matter how you get that information from the tooling manufacturer. You can enter what they give you in here, and then it will automatically calculate the variance between each one. I find that really handy when I'm working with specialty cutters. So for this example, we'll just do a Z rate of 30 inches a minute. We'll do a spindle speed of 5600. You could leave these standard and they're going to be in the ballpark for standard cutters also. Just for this exercise, we'll put some numbers in so you can see how it's going to change.